So for our first day of statistics, I'll first define statistics for you, and then we'll talk about describing important features of statistics. First of all, the way I would like you to define statistics is the collection, organization, and interpretation of data. So like we did with our M&M lab in class today, we collected some data and then we put it in tables to organize it, and we're going to use that data to start interpreting what's happening in bags of M&Ms or in other more important real-life situations as we go through the unit. All right, one of the big ideas in statistics is that we need to be able to describe our data, and there are three important descriptions of data. So 3 data descriptions. And those 3 things that we use to describe data are, first, its shape. So what that means is we'll end up graphing our data, and we'll look at the shape of that graph, or we'll be given a graph and we need to be able to describe it. So with shape, we either have graphs that are symmetric, or we have graphs that are skewed. Those are the 2 differences we're looking for with statistics graphs. So symmetric data might look something like this. It may not be perfectly symmetric, but I could draw a line somewhere near the middle, and if I fold it, it'd be about the same on both sides. One of the things you need to get used to in stats is that we're going to use words like approximately, and it seems to be a lot because no data, no real data is perfect. You'll never get perfect little answers. So we'll say things like, yeah, this graph is approximately symmetric or seems to be symmetric, and that's good enough. So we would call this roughly symmetric because it's mound-shaped with one peak. Our other kinds of graphs are skewed graphs, so they are not symmetric. They have skew. And you might have a graph that looks something like this, and yeah, I'm drawing a lot of histograms because that's the most common kind of graph we'll have in statistics. This graph is definitely not symmetric. If I fold it in half, it looks very different on the sides. So we say that this has skew, and the direction of the skew is the direction of the tail, the direction where the least amount of data is. The majority of it's over here on the right, but then it's kind of strewn or skewed or thrown, scattered off to the left. So this graph would be skewed left. Likewise, we can have graphs that are skewed to the right. Something like that is skewed to the right. Okay, so our descriptions of shape of our data are symmetric versus skewed. Our second data description is the center, where approximately is the middle of our data. And again, it's approximately. When we look at a symmetric data set, the middle is at what we kind of think of as the balancing point. Okay, if this was a seesaw, where would that fulcrum be? Something like that. That would be our center. Mathematically in statistics, when we have symmetrical data, we talk about the mean as a measure of center, the average, and we did those earlier. If we have skewed data, the median is actually a better measure of center. Because what happens in skewed data is these numbers way out here will pull the overall mean higher. Think about if in class today I asked everybody how old they were. You would all be clumped around here, I'm out here. And if we took the average of all of your ages and mine, by adding my age in and dividing by however many people in class, that would pull the mean higher because there's skew to the right with my age. So when we're talking about center of data, We want symmetric data, and that's when we talk about mean. But if we have skewed data, we need to talk about median as a measure of center. The third and final way we describe data is its spread. Whoops. That's talking about the variability in the data. How spread out is my data? Is it really consistent? Is it a nice kind of narrow graph? Or is it all over the place? Is it a really wide graph? That's a measure of spread. It's variability or consistency. So in general, we think about how close to or far away from the middle, the center, are the majority of points. So spread is a measure of how far away from the mean or the center we are. So if we're talking about symmetric data again, we'll talk about the standard deviation as a measure of spread. And if you remember from class, the standard deviation is a measure of the distance from the mean. So mean and standard deviation go together, so mean and standard deviation are used to describe center and spread of symmetric data. If we have skewed data, we would use the interquartile range to measure the variability in the data. Okay, so again, we have three measures of variability of our, or three measures of three descriptions, sorry, of our data: shape, center, and spread. We will do much more practice with that in class tomorrow. Have a good night.